Module 1, Transformers and DC Machines. Introduction. Welcome to the Electrical Machines Laboratory course. In this course, we will explore the practical aspects of transformers, DC machines, induction machines, and synchronous machines. You will also perform experiments to understand their operating principles, performance characteristics, and key measurements. By the end of this course, you should be able to confidently conduct standard tests, interpret results, and connect theoretical knowledge to real-world applications. In this first module, we will focus on transformers and DC machines. Section 1. Transformers. Transformers are among the most fundamental electrical machines used to step up or step down voltage in power systems. In the laboratory, several standard tests are carried out to determine their characteristics. 1.1 Open circuit test. The open circuit test is conducted to determine the core losses and magnetizing reactance of the transformer. One side of the transformer, usually the low voltage side, is connected to a rated supply. The other side is left open. The input voltage, current, and power are measured. These measurements give an indication of the iron losses since copper losses are negligible due to the small current flowing. This test provides data for modeling the core branch of the transformer equivalent circuit. 1.2 Short circuit test. The short circuit test is used to determine the copper losses and equivalent series parameters. The low voltage side is short-circuited. A reduced voltage is applied to the high voltage side until rated current flows. The input voltage, current, and power are recorded. This allows us to calculate winding resistances and leakage reactances, which are essential for predicting voltage drops and efficiency. 1.3 Experimental determination of circuit parameters. By combining results from the open and short circuit test, we can model the transformer's equivalent circuit. The magnetizing branch parameters come from the open circuit test, while the series resistance and reactance come from the short circuit test. 1.4 Efficiency and regulation measurements. Efficiency is a key performance index. It represents how effectively input power is converted to output power. Regulation, on the other hand, is the change in secondary voltage between no load and full load conditions, expressed as a percentage of full load voltage. Load test, where the transformer is actually supplying a load, allow us to measure both efficiency and regulation under practical conditions. Observations are compared with theoretical predictions based on the circuit parameters. 1.5 Harmonics in three-phase connections. Transformers in three-phase systems may exhibit harmonics, especially when certain winding configurations like delta or star are used. By observing the waveform of currents and voltages under load conditions, we can detect the presence of harmonics. This has important implications for power quality and machine performance. Section 2. DC machines. DC machines, including generators and motors, are versatile devices widely used in laboratories and industries. In the lab, we focus on measuring their parameters and performance characteristics. 2.1 Measurement of circuit parameters. The resistance of field and armature windings can be measured using standard ohmic methods. Knowing these resistances is critical for analyzing machine performance. 2.2 Performance characteristics of DC motors. Separately excited motor. In this machine, the field winding is energized separately from the armature supply. It allows independent control of flux and speed. Shunt motor. Here, the field is connected in parallel with the armature. It provides nearly constant speed characteristics, making it suitable for applications like lathes or fans. Series motor. The field is in series with the armature, resulting in high starting torque and variable speed. This makes it useful in traction and cranes. Compound motor, a combination of shunt and series fields, providing both good starting torque and relatively constant speed. Each type of motor has its own load test procedure, where speed, armature current, input power, and output power are measured to obtain efficiency and torque speed curves. 2.3 Performance characteristics of DC generators. Separately excited generator. the field is powered by an external source, providing stable voltage control. Shunt generator, the field is connected across the output. It shows good voltage regulation under certain loads. Series generator, with the field in series, voltage increases with load current, though it is rarely used in practice. Compound generator, a hybrid connection offering better voltage regulation and wider applicability. By conducting load tests, we plot output voltage versus load current, efficiency versus load, and understand how each configuration behaves under real conditions. In this first module, we explored transformers and DC machines in detail. We covered standard tests like the open circuit and short circuit tests for transformers, methods for determining circuit parameters, and efficiency and regulation measurements. We also examined DC motors and generators, highlighting their different configurations and practical performance characteristics. Now, let's move on to Module 2, where we will focus on induction machines, synchronous machines, hysteresis observations, and motor drive tests.